All right, let's get started. So hello and welcome everyone to today's webinar, the second part of our two-part series on lightning fast DDoS detection with FastNetMon. All right, I'll pass you over to Pavel. Pavel started his career as a software engineer in domain name and hosting industries. Throughout his career, he worked very closely with networks and shortly moved into network security became his passion. Pavel specializes in implementing and operating of different network telemetries protocols such as S-Flow, NetFlow, and IPNIC. His all-time favorite protocol is BGP. Thank you for joining us today, Pavel, and I'll pass it over to you.
Hello everyone, I'm Pavel, and in this presentation we will continue on our conversation about DDoS detection using a tool called FastNetMon. This part will be focused on practical part. I hope you remember my main topics from previous conversation where we covered like what is FastNetMon, how it can be integrated in your network. But it was more about theory, how you actually can to understand what is the tool, what its offerings. And this presentation, I will focus on very practical parts. So we will start from step one, like preparing Linux servers to install FastNetMon, installing FastNetMon. Then we will iterate over integration with network equipment. For simplicity, I decided to use MikroTik for my test, but of course, it's not like FastNetMon. It's not limited by MikroTik equipment, and it can be used by with any equipment which actually supports standards as NetFlow, IPNIC, BGP. But for this presentation, I decided to use MikroTik because it provides a quite clear way what we're actually doing, how we're actually doing. And by the end of this presentation, you will have complete integration about automated black hole. So what we are going to implement? We are going to implement ability to create BGP annonces when some specific host in your network is under attack. And we will cover it in every possible detail. So in the future, just to deploy FastNetMon in your specific network, you just need to, start looking on this presentation and implement steps which actually differ from your equipment, and then it will work fine. So I'm very open for any kind of feedback, and FastNetMon, since first days was built using community feedback. It's completely community-driven project from perspective of ideas, cases. And in this case, so you can use any contacts to contact me. So happy to talk all the time. Let's move next. So FastNetMon installation. FastNetMon installation is very simple process. And you don't need to, compile anything on your machine. No. It's not that complex. And for your convenience, you just created install application, which actually can install FastNetMon, install dependency. But inside of it, this tool may sound, complex. And because, of course, if you have experience with like some deployment of some really sophisticated software, installation can be hassle. Like lots of errors, lots of questions, like lots of, sometimes cryptical fatal messages, which, you have no idea how you can find them in Google. It's nothing from it is in case of FastNetMon. It's extremely simple. What actually our install app doing, it just checks what is your Linux distribution. And for this specific case, I will use Ubuntu 20.04 LTS. And I would recommend that as one of the really great distribution because we have great support for Debian. We have support for variety of Red Hat-based distributions, and also we support for Alma Linux, Rocky Linux. But Ubuntu, from perspective for FastNetMon, is actually one of the best. Why? Let me explain. Because of course, different distributions offer different options. But for FastNetMon, it's extremely important to have a network stack and as fast as possible, because FastNetMon is built around all network capabilities available in Linux. And what we actually need from FastNetMon, we need Linux kernel, which as possible fresh as you can. Of course, we are not talking about installing current version, which is unstable, which may have bugs. But if your distribution supports latest kernel version, it's a great option to use it. And one of my favorite things about Ubuntu is that they offer so-called hardware enablement stacks. And instead of using like a single kernel version, which was shipped with like when distribution was released, which is case for like real distributions and any kind of Red Hat based one, you can update like your Linux kernel from time to time. What is the point of it? Greatest point is performance, because lots of people working on Linux, and all the time when there is new version, you may expect some small change, some improvement, maybe a few percent, maybe sometimes actually 5%. So I see no reasons why you should like avoid it, because for large deployments, it's extremely important to have really fast network posting. So let's start from installing FastNetMon. So first of all, we need to identify that we run on Linux. And in this case, we use Ubuntu. So we can confirm that this machine is Ubuntu machine. And then we need to download installer code, which is quite simple app. It's not a large one. It's actually not doing anything complex internally. It just checks what's version of your distribution, then makes small changes from Linux kernel configuration options, and then just download binary packages. Okay, so we are downloading installation tool. We need to start it. And then you can see it's really simple. It's really fast, and we can do it. And you can look at on this video. So we have some disclaimer, and I would recommend signing up for our mail list, because we are not mailing you frequently, but if something happens, like some security issues, some important updates from FastNetMon perspective, it will be we will use it. So not from advertisement, nothing for constant messages. So you can see that's literally all. It's fast. It's very convenient, and you can see it was installed using your package manager. And of course, if you use a different type of Linux distribution like Red Hat or maybe Alma Linux or Rocky Linux, it will be a little bit different. But again, we will use RPM packages convenient for your system. And we are not polluting your system with like random binaries, which will be like very complicated to update in future. Nothing like this one. And you can see we have daemon called as tool like FastNetMon. And you can see after installation, it's launched automatically. It works already for you. Of course, it's not enough to just install it, because sometimes people just install it and expect like then their service will be covered from DDoS. Unfortunately, it's not that simple, and still we need some information about your network or your equipment, and it cannot be detected automatically without your involvement, because network equipment configuration is very complicated. It's not something we can do for you, and that's why we need a little bit more steps to finish initial configuration of FastNetMon. So, and what we will do, we'll move next. So we have FastNetMon up and running on your favorite distribution. And we have no limitation from FastNetMon perspective. We have no limitations about type of machine used to deploy FastNetMon. It can be cloud, private cloud, public cloud. It may be physical server. It may be virtual machine. In some environment, it may be Docker container and Kubernetes cluster. So we open for every kind of options to deploy Linux binary available in market. And if you have something fancy, which is not covered in some ways, or need some changes from FastNetMon, feel free to reach us and we'll consider your feedback. So we finish it with installation of FastNetMon, which is great because, for many tools itself, this process can be very, quite complicated, long, sophisticated, because it's not the case for FastNetMon. You can see you just need, decent bandwidth for your server. It's actually one of the longest parts of FastNetMon installation where you actually download package because, we have customers around the planet, and for many places connectivity can be slow enough, unfortunately, because not everywhere we can expect great connectivity with our main server deployed in London. But so just a few more seconds and then you have FastNetMon. So again, it's not enough to just install FastNetMon because we installed on server, and server just one of the thousands of machines which is in your server, in your network, and we cannot have all information because for now, from perspective of FastNetMon, we can see only traffic which is coming to this specific server. In some cases, actually, it may be useful, and FastNetMon can work this way. So FastNetMon, in addition to telemetry protocols as ISFlow, NetFlow, or IPFix, FastNetMon can read information directly from mirror or span ports, which is quite useful if you, for example, if you use software routers, or you want to detect attacks only for specific server. But FastNetMon also can work in a more general case. So it can actually detect attacks targeted to any host in your network, and we will cover this part in more details. So first of all, to have information about what's happening here in your network, what's happening, like what kind of traffic we have, we need to enable telemetry. And in my case, we will use MikroTik CHR deployed in Google, in public Google Cloud, but it's just some details about my lab. It may be physical device, or it may be different piece of equipment. But what we need on this step, if you use different vendor, you just need to enable ISFlow or NetFlow or IPFix telemetry and set FastNetMon as a collector for this kind of information. Let's look how it can be done using MikroTik. So let's begin. So of course, we need to connect to router. Then we need to enable telemetry. For many routers, you actually can control how many flows your router can maintain, because this metric is very important, because by default, many routers, they use quite strange configuration for net flow, for number of cache entries, for duration, because net flow is extremely versatile protocol. It can be used for very different things, like audit purposes, like SIEM purposes, like traffic billing purposes, and for every case, number of cache entries and timeouts are very different. And then there's those that are best, they just use some safe values which do not degrade your equipment, but they don't work well for every single case. And in this presentation, we're talking about DDoS, and DDoS is it's quite unique beast, because we need to receive information about what's happening in network as fast as we can. Because for billing purposes, we can delay delivering information that customer downloaded, maybe like 1 gigabyte file from maybe Google for a few minutes. It doesn't change anything. It's not that important to have it like with 1 minute delay or 60-second delay. I mean 10-second delay. Of course, it's way better to have it faster, but it's not time critical kind of application. But DDoS is time critical application. Why? But the problem is, for example, let's imagine like we can use default configuration from MikroTik, and in this case, you can see So it was 30 minutes. Default one is 30 minutes, which actually means if your customer downloaded something, you may have the information faster than 30 minutes, but it may be longer than 30 minutes. What is the problem? Problem is that DDoS is not a thing which, increases performance like by 10, maybe megabits in hours. Unfortunately, DDoS can start from something like 10 megabits and then reach 10 gigabits in matter of less than 1 minute. So if we maintain our default timeout for flows as 30 minutes, what will happen? Unfortunately, our network will be dead way before we receive any information from routers. So it's definitely not a point for DDoS detection. We need to have this information as fast as we can, like I would say immediately. But there is a catch because we cannot say because for routers, flow tracking is a quite complicated task because router need to maintain memory entries for every single flow which actually arriving in network or leaving network. It's quite a CPU intensive operation. It's memory intensive operation. And just setting like 0, like second expert, it will overload routers, flow tracking system easily. So we select something in between. So typically we recommend using value in range of like 15 seconds or 30 seconds for active flow timeout and inactive flow timeout. What does it mean, active or inactive? It's not clear because we are talking about flows. How flow can be inactive? It's unfortunately, it's quite misleading naming. What is the difference? Active means that the flow will be exported when it's still running. For example, customer is downloading maybe 10 gigabyte file. And instead of exporting as a single flow, which actually means customer downloaded 10 gigabyte file, that's all from IP1 and port X, fine. And that's exactly what we have with active timeout. But with active timeout, we can split large flows in small chunks and deliver them every timeout seconds. So if we change our configuration for flow timeout from 30 minutes to 30 seconds, like even if customer downloads this 10G file for a very long period of time on very slow link, we will receive information updates like customer downloaded 100 megabytes from 30 seconds. For the next period, maybe 200 megabytes. And it's a way how we can update information on active connections, which is for some, and also it may be some long pooling connection, maybe WebSocket connection, because there are many applications who actually just establish session and then keep it forever or almost forever. And then it's extremely important to avoid waiting for termination of this session and then router will export it, but just update it frequently. What then is inactive? Inactive one is actually similar, but it happens, it's delay between which actually terminate connection. But when I say terminate, it means RST or FIN for TCP protocols. And of course, for UDP, there are no such things as connection termination. There is a thing like timeout, which is quite close. And then so it's time between connection was terminated as part of TCP protocol connection shutdown, or it terminated by timeout in case of UDP. And then after that time, we receive information from router about this specific kind of traffic which was observed by your routers. So what we are going to do, of course, we are not going to use it with 30 minutes because it's too much. So instead, we set it to 15 seconds, which is, great compromise between impact on router itself, because again, if we can set like 1 second, because it will generate lots of packets from router to FastNetMon. And but it's 15 seconds is something in between. It offers quite fast detection time, and in the same time, it doesn't overload routers so much, because of course, one of the things which is extremely important is flow tracking, because in some cases, unfortunately, flow tracking can have impact on your router's performance. And when I say impact on router performance, it's not about overloading flow expressing engine, because when you overload flow expressing engine for hardware router, it will not impact your, forwarding process. But for software routers, which is MikroTik in this specific case, it will. So by enabling NetFlow with quite harsh configuration, you can actually just degrade your network without any kind of DDoS. So be very careful with those configurations. So, okay, select everything we have in place, and so you can see we have some information about like when we actually enable flow tracking for MikroTik. You may notice, so we got some active flows in network. So 5 active flows, which is great. And flows, what is flow? Flow is actually a unique 5-tuple of source IP, source port, destination IP, destination port, and protocol. So flow, it's every unique 5-tuple with all such elements. So if you have like connections between just 2 hosts from same source port and same destination port, same protocol, it will be just 1 flow. But if you start using 2 ports on destination machine, but again, like in 2 ports from source machine, it will be 2 flows. And flows is a great thing because they're quite useful in case of DDoS, because one of the problems we have is DDoS attacks. That's attacker creates plenty of them, and it's actually one of the points of DDoS attack to cause degradation, to cause overload, to exhaust your resources. And so flows reflect what we have quite well. And next thing, we just need to add FastNetMon as recipient for this kind of information. Let's do it. It's target configuration, or it's for different vendors, it's called agent or collector. So again, those timeouts also very important. I'm not going to explain why, but just for safety reasons, set every timeout you have for your router for at least like 30 seconds, because plenty of them, and NetFlow template timeouts, they mean actually that until we receive this template, so-called template, we cannot decode any information coming from router, because it's like just a blueprint of what we have in telemetry. Before we receive it, we cannot say for sure what's actually coming to us from router perspective. So let's set IP address of machine which actually runs FastNetMon. So we have finished configuration of telemetry protocol from MikroTik side. So from this point of time, we will receive something from FastNetMon. But will it work out of the box this way? No, because we need to say what kind of protocol FastNetMon need to expect, and we need to finish basic configuration of FastNetMon. So let's do it. So what we have here, let's start. Before we start talking about FastNetMon itself, we need to be sure that network works fine because all the time people, tend to blame networks for literally everything. And in FastNetMon, we're in quite bad position because sometimes, when you enable telemetry and you can see all information from FastNetMon as you expect, then you blame FastNet, it's tool to blame because it's not receiving information for some reasons. But according to our experience, unfortunately, one of the main reasons why FastNetMon actually doing nothing, doesn't show any traffic, doesn't detect attack, for some reasons telemetry wasn't delivered to FastNetMon. So, and first thing we need to focus and to confirm that FastNet machine with FastNetMon actually receives telemetry. It's extremely important, and let's keep away from FastNetMon for a short period of time. Let's use old good tool called TCP dump. What TCP dump can say? What can it show? Why we need it? What we need to dump? TCP dump can say the server with FastNetMon actually sees some traffic for NetFlow protocol. By default, NetFlow protocol uses port 2055, and let's start command on machine which actually runs FastNetMon, just to say for sure when we receive information from router, telemetry information from router. And from router's perspective, what I'll do, I'll start some artificial bandwidth hogging process, which just emulates kind of DDoS and saturates quite serious bandwidth. And then main point to just cause router to generate more packets and send some telemetry information about what actually router is observing in this case. So on left side, you can see peak load of ports. You can see some metrics about MikroTik performances, CPU usage, and when we start our artificial attack, you may notice it by graphs. So let's do it. So you can see CPU 0, very small lot of traffic, and let's launch TCP dump. Ooh, nice! Immediately we can see that some traffic is coming to machine and make it better. Start emulated DDoS attack. And what will happen next? You can see it's slow moving, but we expect lots of I started attack generates lots of packets, and we expect plenty of telemetry frames from router. But you can see it's slowly moving. Yay! You can see it was batch. It's this is how routers implemented because or CPU emulation application or DDoS emulation application. It's just creates plenty of UDP packets, plenty of them to random ports, and just to simulate what actually happening during real DDoS attack. But in this case, it's exactly what happened. Why? You observe a delay between time when I actually started attack and between batch of packets to port 2050 arrived to machine. Why? It was so-called flow active or inactive flow timeout we configured on previous steps. That's why it's extremely important. And this one was in something like around 15 seconds. But if you keep default configuration, it will be 30 minutes, and we will finish this presentation way before you actually receive any information about traffic. So I hope you got importance of flow configuration. And at this step, we can say for sure that machine is getting telemetry information from a router. What we can do next? So let's open FastNetMon. FastNetMon has a tool called FastNetMon Client. It just shows you basic information about network. It's like helicopter perspective. It's like total traffic, outgoing, incoming traffic in megabits and packets per second and flows. What we can see we can see nothing. Everything is 0. You can see. So this needs to make some changes from perspective of FastNetMon. So FastNetMon community keeps every single configuration in just text configuration file in etc/fastnetmon.conf. So because FastNetMon uses different packet processing systems, we need to say for sure which one actually required in this specific case, because we cannot enable every single of them, because it will open lots of ports, it will enable features you don't need, it will use more memory. That's the reason why we keep them disabled by default. So, but in this case, first thing we need to do, we need to enable NetFlow plugin, which actually in charge of NetFlow processing. Let's do it. So first thing, it's NetFlow port. We'll keep it default one. NetFlow host, just 000 means listen on every available interface on specific machine. So if you have more than one, you need to set specific one. It may be private one if you actually have private and external IP ranges for same machine at the same time. You can set sampling rate, just override default configuration. And most important one, NetFlow on. This one will enable NetFlow processing subsystem inside of FastNetMon. So next extremely important thing, it's average calculation time. This thing directly it changes traffic configuration or traffic calculation processing from FastNetMon side. And if you set it to incorrect value, which doesn't match your router configuration, what you will have weird traffic measurements from FastNetMon. They may be too low or too high or too spiky. And that's the reason why this thing is the next most important thing after flow timeout configuration, because this metric, it must match what you actually set for flow timeouts. That's very simple, because it's actually just time period for which FastNetMon calculates average value. So it needs to be almost in sync what you have from router's perspective, but it may be a little bit bigger just to know smooth spikes of traffic as well. So in our case, flow timeout was 15 seconds. So what we can do here, we can set it this way. This one, just keep it. So in this case, we set very simple configuration of FastNetMon. It will recalculate traffic every 30 seconds. That's very simple. So, and one of the most precise configuration of FastNetMon. It's not the fastest configuration, because you may change configuration to detect spikes of traffic way faster. But this one is the safest and most reliable. So you may expect that traffic in this configuration will match what you actually see from routers with quite good good precision. So let's set it. Finally, we need to save everything. Next important thing that we all the time, when you change configuration of FastNetMon, you need to change, you need to apply it for daemon. And to apply it from daemon perspective, you just need to restart FastNetMon, because if we don't have any logic in FastNetMon to apply configuration changes in the runtime. So if you changed anything, you just need to restart FastNetMon. It can be accomplished by using your Linux distribution service management. So in this case, service FastNetMon restart. Let's look again on FastNetMon client, what we can see here. Again, we set timeout to 30 seconds, which actually means that we may expect any updates in 30 seconds. Let's have a patience. Let's wait. Again, time is ticking. You can actually see when every second passes, when FastNetMon updates traffic calculated in delay. Yes, finally, you can see it was actually a little bit faster than 30 seconds, but we got some other traffic, which actually matches from what we have from our packet emulator. It's 22,000 of packets per second. But why? Why other traffic? What is it? Strange. So, because, you know, for network, we expect to talk about traffic in terms of incoming traffic or outgoing traffic, but what is other traffic? That's one more piece of information we need from FastNetMon perspective. FastNetMon need to know what networks are your networks, and what FastNetMon is actually saying by classifying all traffic as other traffic. FastNetMon is saying, I don't know your networks. To say for sure this traffic is incoming or outgoing, we need to know the specific prefixes 1.2.3.4/24 is actually your prefix or your neighbor's prefix, because it's also important when you have telemetry for a large segment of your network. But in this case, you need to say for sure, like, I need only specific network or if part of it. And that's why we have special configuration file called networks list. It just maintains a list of every single network which belongs to your network segment or your department. So you can see it's just list of CI there represented prefixes. It may be IPv4, it may be IPv6, which we have complete support for. So, but in this case, just add this one. Of course, it's expected to have many of them because, you know, this one is a lab, and real network, it may be like thousands or way more prefixes. So list every single of them. It's not a hassle for FastNetMon. So don't worry to overload it. So then if we add this prefix, and we need to update configuration again. We restarted FastNetMon to apply because network change is a configuration change, and we changed it. And again, let's wait 30 seconds. And look what happens. Remember, back in time, all traffic was classified as other traffic. But then we added network, which we used for in our specific scenario for this specific attack. Yes, finally, you can see, we see most important information. And now it's in direction of, we can see host. It's 10.166.0.14, which is host I use for emulated DDoS attack. We can say incoming, batch of incoming traffic. It's 23,000 of packets. It's not so much for real network. Many real networks can handle it and will not consider this specific one as DDoS. But for lab, it's quite dangerous because you can see on the left side, we use lots of CPU and routers, already on 13%, and the software routers. It will increase attack a little bit. It will start dropping packets, which is bad. And also you may notice that like on the right side of opposite of this host, it's called banned, which means that FastNetMon already blocked it in some way. And you can see ban list, which actually just lists every single network blocked by FastNetMon. Why it was blocked? What happened? I'll focus on this stuff a little bit later, because in this case, ban just means that this specific host exceeded our default configuration for thresholds, which set by default to around 20,000 of packets per second, or around 300 megabits. Of course, it doesn't fit to any network, because for some networks, 1G of malicious traffic is dangerous. For different network, I mean large-scale operator, telecom networks, 100G of malicious traffic is nah, we don't care. So it depends on your network, because you need to know at which period on which bandwidth your network will start degradation. And we'll focus on it a little bit later. So we have perfectly working FastNetMon, which actually receives information from your routers, which also shows every single host in network, because in this case, we just have single host in lab. If you have many of them, you will see list of all hosts in your network, and of course, top talkers. And from perspective of top talkers, they are most important for our case, because if they hog lots of traffic, then they may be target of actually source of DDoS, which is quite common, unfortunately. So because this host was blocked, you can see FastNetMon blocked this host. One of the first things, if you just misconfigured FastNetMon, you need to unblock it, because all the time we change configuration, we look what happens, and in some cases it may block something you don't mean to block. And so we have nice command line tool called FastNetMon _API _client, which is more interactive versions than FastNetMon client, because FastNetMon client just can show you how much traffic you have in your network. But in this case, you can make some actions. So let's request ban list. So our host us in FastNetMon client, but what we can do next, we can save it, we can unban it. Let's do it. See, it's blocked. And also FastNetMon has option to automatically unban blocked hosts for DDoS after some period of time. And so FastNetMon can do it. So because what is the point to keep host blocked when attack stop it? Because it's one of the main points of FastNetMon to automate your things, to automate DDoS detection, because it may be middle of the night or early morning, and you don't want to wake up just to find out, who actually is a target of attack. But also, attack can be long, and if you actually identify the attack, and then you may decide to sacrifice part of your networks and block it, but then again, you need to wait when it actually stops. And FastNetMon can do it for you, because what is the point to keep host blocked more than needed? So when attack started, should it block it? I think so. And FastNetMon can do it for you. So when actually amount of traffic, because I just stopped simulated attack, and FastNetMon will recalculate counters in 30 seconds. And if they fail lower than we had threshold in our configuration, it will unblock it. And you can see, so a little decrease of traffic, but it's still banned. So, and if you don't want to wait, we can unban it manually. It's also way faster. Okay, see, it just disappeared. So on this part, we finished configuration of NetFlow. We have telemetry coming to FastNetMon. We added every single network into FastNetMon configuration, and FastNetMon was able to identify which direction of your traffic is incoming, which one is in outgoing, and then FastNetMon was able to block traffic. But when FastNetMon calls like host blocked, does it actually block anything? No, it doesn't. So what actually mean? It's nothing. FastNetMon is not stopping traffic to specific host. It's just abstraction. In only way you can see like host blocked or not, it's just in FastNetMon client configuration and output, like it's blocked. But there are no changes, there are no filters, there are no firewalls deployed in this specific moment by default. But FastNetMon actually can do it. And it's subject of next slide. So what is the point of automated black hole? To automate black hole. So at this point of time, we have FastNetMon in perfect shape to actually detect attack. And FastNetMon can find out like what is the host of what is the target of attack. And next thing, but FastNetMon can just print blocked in output of command line tool, which is fancy, but it's not solving anything. But again, it may be very important because, you know, if you're under attack and you have hundreds of thousands of hosts in your network, at this point of time, you know, you can find out attacked host and then block it manually. But it's not the point of FastNetMon. FastNetMon wasn't built to help you. Again, you're away, you know, somebody woke up in the middle of night, your next day, or maybe 2 days, ruin it. No way to stop it. Oh, there is a way to stop it, actually. We can automate it. We can automate everything. Instead of offering tool which can solve half of your problem, we are offering tool which solves all your problem. And what FastNetMon can do? FastNetMon can create BGP annonces for you automatically when it detects attack or when it actually decides that attack stop it. In both cases, FastNetMon can create specific BGP announce in direction of your border routers or your upstream, which is a quite common case for black hole. And when attack stops, it just removes it as nothing happened, and then enables traffic to flow inward or and outward without any issues. So FastNetMon has tool, has integration with 2 daemons for BGP, because FastNetMon is a set you can use to solve your problems. It's not something which dictates what you need to do. It just supports many things, and then you decide what you will do. I personally recommend using GoBGP, but we support GoBGP and XBGP, but in this presentation, I'll cover GoBGP and I recommend using GoBGP because it's really convenient. So you can see this configuration of peering session with backbone of your network. It has IPv4 and IPv6 enabled. We have multi-hop enabled because, again, in my specific lab, I use it in cloud, but in your case, it may not be needed. So it's basic information about ping session, your ASN number, your IP, remote neighbors IP, that's all. Very basic information to establish BGP session. But because BGP is external tool for FastNetMon, and it needs to be configured externally and install it externally. And what we will do, so let's focus on GoBGP. So first of all, GoBGP is external software for FastNetMon. It's not related with FastNetMon in any ways, and we need to use their official site to download binary. Fortunately, again, fortunately, GoBGP as name suggests written in a fancy language from Google called Go. And one of the great things from Go is that it's like statically built binary. It works on any Linux platform. You don't need any dependencies, dynamic libraries, compilation, nothing. And what we do exactly in this case, so we just download it from official site. Inside of it, inside of archive, we have statically compiled binaries. Actually, just two of them, go.bgp and go.bgpd. And then we just copy them into OPT folder just for convenience. So if you want to create package for it or your distribution of this package for it, so let's use it, but it may be a problem for a few distributions that they actually have go.bgp, but extremely old version. And for efficient, not just efficient, just working integration with FastNetMon, you need to we recommend to using version 2.16, because if you use too old version or too recent version, you may experience issues with API integration. So if you use this specific one, it will be best option. So installation is extremely simple. We don't need any complex parts, no compilation, no packages, very simple. So just two binaries. So, and then we need to create configuration for go.bgp as was outlined on previous slide. Actually, really simple, very basic information peering session about router ID, ASN numbers, your neighbors, IP addresses, and some information about AFI and SAFI about this specific session. We are not going to have IPv6 host blocked in this case because it's outside of presentation, but it's already also supported. FastNetMon can create IPv6 announcers for you. So just play it after presentation. So we need to create configuration file and look, just iterate over all options we have here. Again, we need to apply configuration as with FastNetMon. Just to apply configuration change for go.bgp, you just need to restart it. But to restart it efficiently instead of doing it manually, we can create systemd unit file for it, which is again very simple. It's just very standard. Nothing. It's boilerplate text. It's like description, some basic information when service actually starts, pass to binaries and pass to configuration file. That's simple, but it's for your convenience because it will start on when your server starts, and you can use standard tools for restarting daemon, which is way more convenient than running it all the time from your console session, because it doesn't scale and it's not that reliable. So we create systemd configuration file for service. And then finally, we apply configuration for systemd itself. And then we enable automatic start of go.bgp on server restart, because of course, server can be restarted at any period of time without, any notification. And then we start go.bgp. And is it enough to set session? Okay, see. It works. We added peer configuration. And then we need to enable go.bgp integration in FastNetMon. So FastNetMon has lots of stuff in it. And just take your time and read what we have in FastNetMon conf configuration file. You may find many things we are not talking about part of this presentation. But in this specific case, we just need to enable go.bgp integration. We have options to set communities, which will be added for specific unknowns when we create it when attack happens. So we can set different communities and next hops for IPv4 and IPv6 sessions. So you can change them accordingly as you prefer. So from this side, from this step, we have a BGP session, but BGP session, this part, it's configured only on our part. Of course, it needs to be set from opposite side, because how BGP session works, it's not enough to set it from one side. So Then we applied configuration change. Then we need to apply configuration change for FastNetMon just to let FastNetMon know, like, okay, we have GoBGP now, and instead of just printing fancy black hole in FastNetMon client output, we need to actually create BGP annonces, because only BGP annonces can change routing in your network, and what we are going to do. So okay, let's check that our integration between FastNetMon and GoBGP works. It's because there are many things, there are many moving things in deployment of FastNetMon, many of them. And it's extremely important to move step by step, because as I highlighted previously, it may be, you may have some issues with FastNetMon, but it may be missing like some issues with BGP session. It may be some issues with telemetry. It may be some issues maybe with firewalls actually blocking telemetry, because that's why it's important to go step by step for every significant configuration change in FastNetMon and confirm on every step that, again, it works as expected. What we are going to do on this specific part, we are going to manually block host to confirm that FastNetMon will create BGP annons locally. We are not checking propagation yet, because it's a different topic, but we are checking that FastNetMon actually can create annons on GoBGP. That's the only thing we check, nothing else, because you remember we didn't establish session with anything outside of our box. We're just doing all tests locally. And so let's block specific host. Okay, in FastNetMon client, we can confirm that different host 077 was blocked. And then we need to check what kind of annonces we have from GoBGP side. Okay, we have like session established, but let's check what we have. What we actually have here, it's a little bit different from what you output about BGP session status from what you can see from Juniper or Cisco. But again, you can easily decode it. Some capabilities of neighbor of our specific BGP session. But most important one is advertised, which actually means that GoBGP is sending something to opposite side. What's exactly it's sending? And we also have command which can actually show what exactly we are sending to opposite part, because we need to confirm that we are sending correct one. So finally, you can see it's exactly as we set it in FastNetMon configuration. So network, as we blocked it from FastNetMon API client, next hop, default 1000. And most important, community is exactly as we said, because this community 666 is kind of standard for many operators, and it will block all traffic to or from specific host. And so we can see that FastNetMon's integration between GoBGP and FastNetMon works absolutely fine, exactly as we expected. So we are very close. Default configuration of FastNetMon, because you remember when FastNetMon blocked host immediately after we pushed some traffic, artificial attack traffic to it. And it actually blocked it because our default configuration was set to 20,000 packets per second. And remember, this my emulated attack was 22,000 packets per second. So that's the reason why FastNetMon blocked it. And also in terms of bandwidth, we keep 1,000 megabits as bandwidth limit, but this one is default one. It will not work for your network. And for your specific network, you need to understand what's your borderline value. What is borderline value? Because it's lots of numbers. I will be perfectly fine if you blame me for asking too many numbers from FastNetMon, but problem is that those numbers are extremely important because every network is very unique, and we cannot say and we cannot guess this number for you because those values are just examples. They may fit your network or they may not fit your network, and you need to know which value is important for you because typically we are calling about DDoS. DDoS is extremely, it's kind of emergency stuff. It degrades your network. And what value you need to put here? Value on which your network starts degradation for one reason or another. It may be a router overload if you use software routers. It may be your bandwidth from ISP limitation because if you have just 1G of connectivity with your ISP and attack is more than 1G, like mission accomplished from attacker side, you need to block it before it actually reaches 1G. So set it accordingly. And if you know for sure that your router cannot handle more than 100,000 packets per second, then it's your limit. Set it a little bit smaller or a little bit bigger just to be sure. And then that's your threshold configuration, because the point of FastNetMon to stop it before it causes havoc on your network, because before your network is dead. So that's about thresholds. And all the time be very open to making changes, tests, adjustments, because you still need to play with values, because sometimes you can see set value which is too high and you will miss attack, or you may see set value which is too low and it will cause lots of blockage. So just be careful and disable BGP integration for a short time to avoid impact on real traffic, and just keep alerts and look what happens. Of course, FastNetMon has global thresholds, and of course you can create thresholds for specific hosts, so-called host group. So you can see example from right side. You may create any number of host groups with custom thresholds. So it's useful when you have different traffic profiles in your network. Like you have caches, or you have residential customers, and you have business customers. For any of them, all of them, you need to maintain a little bit different values. Just align it with what is their bandwidth elements, what's their port capacity, what's their expected traffic. So this one will show us how it works together. So let's look this presentation. So in this video, we will start from BGP configuration. So because we created BGP session from FastNetMon, but again, it's not enough to create it from FastNetMon. We need to configure it from opposite side, and we will do it from router. Oh, sorry. So again, open BGP configuration from your router. Of course, for Cisco and Juniper or anything else boxes, it will be command line. But you can see this one is a way more convenient to show how it works in a vendor neutral way. So again, same information as we did from Go BGP side, but a little bit different interface. It will be same from your Cisco Juniper box. Same information, like multi-hop needed, what's hold timer, output, input filters. For almost all vendors, it will be exactly that way. So, okay, apply configuration. And remember, on opposite side, we have FastNetMon. So, and you can see what is the BGP session status. Okay, it's established, which is great. So what we'll do next? Next thing we will show a routing table content, just to look what is inside. Because when we create unknowns from GoBGP side, like when FastNetMon uses GoBGP to create unknowns on FastNetMon side, what we expect from router? From router, we expect to create black hole route. And that's what we'll check on the bottom of screen. It's a list of unknowns create like in a router's routing table, because we expect some changes here. So we have established a BGP session between GoBGP and MikroTik. And let's add more graphs. Okay, this thing is MikroTik specific. We just need to tag all unknowns received from GoBGP with specific community and tag them as black hole unknowns, because black hole unknowns in MikroTik will literally block all traffic for specific host, and that's what we are actually trying to accomplish. And also we create we apply filter for community. So what we need to do, we need to mark it as black hole. To accept set black hole type black hole. Of course, for your router, you need to change it accordingly, but so it's out of scope of this presentation. You just need to adjust your input output filters to propagate to specific tables. So when actually FastNetMon announces something, some networks towards your router, then you need to accept annonces created by FastNetMon, validate them, and apply what you actually want them to accomplish. You can apply them on your router only, or you may just immediately propagate them to your upstream. It's up to you to decide what you are going to do next. And what's next? As next step, we'll create unknowns, like use FastNetMon to block specific host. So for that purpose, we have FastNetMon API client, which can list blocked host, we can unblock blocked host, and also it can block host manually, because let's imagine just abstract case FastNetMon missed attack for some time, but we can do it for you, and what manually, and we can use it for test. And when we actually create blind host, we expect FastNetMon to create announce from GoBGP, and then we expect GoBGP to announce it. Create BGP announce towards MikroTik. What we expect from MikroTik? From MikroTik, we expect receival of BGP and then creation of specific route for specific host target black hole. So, and you can see that's exactly what here. Let me rewind a little bit. So you can see on the center of screen route list, just two routes, standard ones, nothing fancy. Then we call command to ban specific host from FastNetMon. Look, ban immediately, almost immediately, because this one was propagated from BGP. That's exactly what we tried to accomplish. So can we? Yes, it's fine. So it's proper type, it's black hole. From this point of time, MikroTik will stop blocking all traffic for a specific host. And you can see we can check BGP session status. So we have one prefix from GoBGP to MikroTik, and we can check which one is it. Okay, excellent. Just to check that everything works fine, we can unban it, and look, it immediately disappeared from a routing table. So you can expect that FastNetMon will block hosts very fast and unblock them very fast. So, and from this slide, we finish the configuration of FastNetMon. So everything in FastNetMon can work from this time completely automated way, because I did ban and unban manually, but it can be done automatically. So as we configured on previous steps, you just need to feed some traffic. That's all we have discussed. We covered basic configuration of FastNetMon, from the step of installation on Linux box and the final steps of integration with your BGP backbone. It's just beginning of your long way with FastNetMon, because of course I'm pretty sure that your network is very specific and you have specific cases, specific scenarios. You want more complex operations with annonces. You want to call scripts. You want to integrate with APIs. And guess what? We have great community. In total, we have around 2,000 of people in our community across all our social media contacts channels. And all of them are eager to help you, to share their experience. Because if you face something unknown, strange, somebody may do it exactly the same way, in same time, and then you can check. Or somebody did it back in time, and then you can just, get great story, like how to do it, how to accomplish it, to find out all issues you may experience. And then when you accomplish something fancy, great, it works, just share it. So every single channel, we are very open. So feel free to contact us, like us, subscribe to us, and we'll be happy to hear your feedback. So again, move away from project. You can contact me directly. It's my contacts. So I'm not that useful, as our community, but I still can make some advices and recommend something in terms of FastNetMon. So, and that's time to questions.
Thank you for that, Pavel. There is one question that was asked earlier on in your session, and it was a question about after you installed FastNetMon, is updating it straightforward like installing it was? And I actually linked them to the community edition, the FastNetMon docs, FastNetMon community update process. But it just in general, is the updating easy, just like the install?
It's actually easy because update is just new install. So to update FastNetMon to new version, you just need to wait for our announcement, test in your lab, and then you just run install app again, and it will find out if you use older version, it will update it automatically for you. So all the time we keep backward compatibility. So if you install new binary and we have something new or configuration change in new version, it will continue working all the way without any significant changes until you actually set new configuration options and you enable new logic. So it's very safe all the time. Don't worry about it. And all the time, of course, we recommend installing new version when we publish it. And also from perspective of project, we are working on automating update process to use repositories of specific distributions to update it automatically without using our install app. So it will be way better in future, but still now you just need to start install script again, and it will update version, it will maintain configuration, everything else. You'll just download new binary and install it on your machine. That's all.